Okay, so for this next round, the tough thing about letter C is there's not really an easy choice for the first step. All right, so again, there's 4 choices: solve for x, solve for y, solve for x, or solve for y. And unfortunately, like the last couple examples, there was a nice singular x floating around. But here, x is being multiplied by 3 and 2, y is being multiplied by 2 and -3. And, I just forgot. This system up here is consistent, right? Sorry about that. Just wanted to make a note of that. There is a solution, so it's consistent. But anyways, so there's no easy choice here. So what you just have to do is just make one. And so how about we go ahead to this first equation, and we'll solve it for y, right? So if I solve for y, the first thing I would do is subtract 3x from both sides. So we get 2y equals a -3x minus 4. If I divide by 2, we get y is -3/2 x, and that would be a -2. So we're just going to have to push a fraction around here, all right? And so the next step is to take that and substitute it for the y value there. So again, I like to show that substitution with parentheses, and I'll do it in another pen just so we can see it in its totality and all the math around it. So looking at this situation, what I now have, right, is I've got a distribution to make. So I got 2x. If we make this distribution here, we get -9/2 x. -3 and -2 is a +6, and that equals 6. Okay? What I can see here is I have an equation that's left with a denominator. So what we learned, right, is let's go ahead and multiply everybody by 2, and that'll at least clear things out, and I don't have to worry about fractions anymore. So I get 4x plus 9x plus 12 equals 12. So 13x plus 12 equals 12. Subtract 12 from both sides, we get 13x equals 0. Divide by 13, and it looks like our coordinate that solves this system is x equals to 0. So now we got to go find y. I'll go plug it in. Y equals -3/2 times 0 minus 2. That's 0, and we get y equals -2. So the ordered pair that solves this system, and it's consistent, right, because it does have a solution, is 0, -2. And again, kind of easy to check. These are 0, so they're gone. -3 times a -2 is 6, and 2 times a -2 is -4. So it does in fact solve the system because it solves both of them. And just we're pushing a fraction around. And again, just a reminder, we know how to solve equations with fractions. Just clear the silly things. All right, so that's that one. Again, sometimes you just can't avoid the fractions, and that's why we've been working really hard on fractions. And hopefully you guys have, actually you guys have vastly improved in it. So what about the next system? Well, again, there's no easy choices for step 1, right? Everything, x is being multiplied by numbers, y is being multiplied by numbers. There's just no easy choice, all right? So how about I just kind of stick to what's tradition? We'll solve this for and for y. And I'll do that by subtracting 6x from both sides. So we get -2y equals -6x plus 2. Divide by -2, and we get y equals, it looks like 3x minus 1. So hey, that's kind of nice, right? It's not an easy choice, but at least we don't have any fractions. So we're going to take that and we're going to substitute it for that y value right there. So again, I'll demonstrate that with some parentheses and in a different color so we can see everything around it. Right? So there's my substitution to the other equation. Next step, I have an equation to solve for x. So I just go back and do what we learned how to do. 9x, take away 9x. Well, they actually go away. And so we have 3 equals -6. Right? This is absurd. Right? They are not equal. All right? And so basically, since the variable went away and we went to a situation that's always false, what this means is there's no solution. Nothing will ever work. You cannot find an ordered pair that makes both equations true at the same time because they are never true, right? That's what that math is saying. So this is our first example of what we call an inconsistent system. All right, and so consistent means we have a solution, inconsistent means we don't have a solution, and what you just saw me do is solve a bunch of 2x2 systems using the substitution method. Right, so why don't we take a break from this, and now let's go practice the elimination method, but I'll do that in a video coming soon.